In this video, we'll explore when an unstable radioactive nucleus undergo emissions, may be alpha, beta particles, or gamma rays. So we have to find what's the resulting nucleus, which is more stable, what's the composition, meaning to say what's the proton number, and what is the mass number. But before we go to the question, we need to know the basic that alpha particle, okay, this is the sign for alpha particle, is actually a helium nucleus. And if you can, I need you to remember. So the proton number is 2 and it has 2 proton, 2 neutron. That's why the mass number is 4 here. As for beta particles is actually electrons. And for the time being, if you can just remember, okay, so it will be 0 and this will be -1. So actually what happens when a nucleus undergo a beta emission, that means to say one of the neutron will be converted to a proton and also emit out electrons, which is your beta particles. So the proton number will actually increase by 1 and there will be no change in the mass number. Because why? One of the neutrons is converted to a proton, so the mass number will not change. Alright, and lastly, if the emission is in terms of gamma rays, okay, there will not be any change in the proton number or the mass number. Alright, so without further ado, let's straight away go to the questions. In this question, you have an unstable nucleus, I shall not pronounce it, emits an alpha particle. So first of all, you need to know that alpha particle, which is actually your helium nucleus, which is 42. So let's start with the original 241 and 95. Alright, so it will undergo decay and there will be a resulting nucleus and plus a alpha particle 42. Now remember in class we said that the total number of nucleons, that means your neutron plus proton, and the number of proton itself has to be the same before and after the reaction, the decay, and the relative charge before and after must be the same also. So that means to say the mass number before and after has to balance, and likewise for the proton number. So what is the mass number for this X here? Since if you emit a alpha particle, you take away 4 mass nucleons. That means to say, so the number here will be 241 minus 4. That's why you are left with 237. 237 over here. And for the proton, since 2 protons are emitted out as alpha particle, therefore you are left with 95 minus 2, 93. So if you look at the options, only option A will have the correct mass number and proton number. So A will be the answer. Next, this nucleus X decays by emitting a beta particle to form a more stable nucleus Y. So there's your starting, the mass number, which is the sum of neutron plus proton, also known as nucleon number, is 227 and the proton number is 85. So since it's a beta particle, I need you to recall beta is actually an electrons, and if you remember here, this is 0 minus 1. So there will, since it's 0 here, that means the mass number before and after must be the same. So this will still be 227 because beta particle emission will not affect the mass number. And remember I said it's actually a neutron that's being converted to a proton and emit an electron. So the proton number will increase by 1. So 85 plus 1, this will be 86. So the answer will be D, 227 and 86. Okay, the next question, uranium here emits an alpha particles and then it emits a beta particles. So you do one by one. Let's do with the alpha particle. Let's recall 42. So the total mass number must be the same. So this will be 238 minus 4. So this 234. How do you try again? 234 plus 4 must be equals to 238. Then for the proton number, okay, so it's 92 minus 2, so this will be 90. So this is the intermediate decay. So the final resulting nucleus will be undergo a beta emission first to go to the final nucleus. So beta, like I say, is 0, -1. So let's deal with the proton number. Proton number will increase by 1, okay, because the neutron is converted to a proton. So now there's increase in one more proton, 91, and there's no change in the mass number. All right, so this will be 2, 3, 4. All right, so the answer will be B. They're only asking for the proton number or the atomic number. Another similar question, you have an unstable nucleus, emit one alpha particle first, then followed by a beta particle. So what's the resulting nucleus X? So let's start with the initial one. The mass number is 230, the proton number is 91. So it will undergo decay by a alpha particle, and recall alpha is 42. So let's look at the proton number. So since 2 protons given away, so it's 91 minus 2, so the proton number will become 89. And for the mass number, so this will be 230 minus 4, that will be 226. So how do you check? Add these two numbers together, will give you 230. 89 plus 2 will give you 91. Alright, so this is an intermediate decay, so the final resulting X, okay, is you will get X after a beta emission. So that's your electron 0 minus 1. So as remember, we said the mass number will not change, so it will be 226. And as for the proton number, there will be an increase by 1. So there will be 90. So once again, check. 90 minus 1, there will be 89, correct. 226, 226. So the answer will be C. Alright. So I hope by now you should be more familiar. So this question very similar. It's just that now they say that there's an emission of 2 alpha particles, then followed by a beta. So it's the same thing, 225, 90x. It will undergo, let's say, I call it a Y, but this resulting Y, you will undergo 2 alpha. So for make it easier, I'll just separate them and plus a beta, which is an electron 0 minus 1, 4, 2, 4, 2. So let's deal with the mass number first. Starting is 225. If you take away 4, and then no change, so total take away 8. So that will be 217. And so this 217. And as for the proton number, okay, you take away 2, but you plus back 1. So it's 90 minus 4 plus 1. So resulting proton number will be 87. So the answer will be B. Now the last question is similar. You start with a unstable nucleus. So it will undergo alpha emission first. Let it be your X here plus a alpha, which is 42. So this will become 211. Okay, just double check here. 211 plus 4, 215, correct. And for the proton number, so this will be 82. Then after that, you will undergo another beta emission. So let it be Y here, and that's a beta. It's an electron 0 minus 1, so no change to the mass number 211, and there will be an increase in the proton number 83. So B will be the answer, 211 and 83. Alright, so I hope with this video you are clearer how to find the composition of the resulting nucleus. Alright.